So the branch and bound is the graphical method, and we represent our maximization objective function with the help of the constraints, and then we show the non-negative constraints. So then we will go through our the next topic, which is dynamic programming. In dynamic programming, we will see its characteristics, that the dynamic programming is a program structure is divided into stages, and in each stage, each stage has a number of states associated with it. Then we make decisions at one stage, transform one state of the current stage into a state in the next stage. Then we will find the optimal solution, and for the optimal decision for each of the remaining states does not depend on the previous states of decision, and this is known as the principle of optimality for dynamic programming. And the principle of optimality allows to solve the problem stage by stage recursively. Then the discriminant dynamic programming, for the deterministic dynamic programming, we will also see the deterministic dynamic programming, and it is a type where we determine the optimum solution to an n variable problem by decomposing it into n stages, with each stage constitute a single variable subprogram. And recursive nature of calculation in dynamic programming is that the dynamic programming calculations in dynamic programming are done recursively, in the sense that the optimum solution of one subprogram is used as an input to the next subprogram. Deterministic dynamic programming, in this other part of the slide, is that we, for example, it has three stages, and the decision variables, number of team to allocate to stage xn, and SN is the number of medical teams still available for allocating to remaining countries. Thus, S1 is equal to 5, S2 is equal to 5 minus X1, S3 is equal to S2 minus X2. In general, Sn plus 1 is equal to Sn minus Xn. And to state the overall problem mathematically, we will use the measure the performance of allocating xi variables to the objectives chosen as x1, x2, x3, and so on, and it is given as a maximization of I varying from 1 till 3 pi xi, subject to the constraints I varying from 1 till 3 xi is equal to 5 and xi are non-negative integers. Then there is a simulation, and simulation is the process of rail system designing as a model of what you say artificially, we create the environment of the rail system. So rail system is a process of designing model of rail system. So simulation is a process of designing the model of rail system, conducting an experiment with this model complex real world system. Maybe their experiment is too costly or destructive, or you can say harmful, then we use the simulation instead of the real system. So simulation is the process of designing a model of a real system and conducting a series of repeated trial and errors experiments with this model for the purpose of either understanding the behavior of the system and or evaluating various strategies for the operation of the system. So some applications of the simulations are ambulances, location, and parking lots, distributing system design, personal scheduling, traffic light timing, voting pattern prediction, sales forecasting, or plant layout, and so many like this. And its advantages are that it is flexible to model things as they are, even if messy and complicated, allows uncertainty, non-stationary in modeling, user-friendly computer application. And its disadvantages are sometimes simulation models are expensive and take a long time to develop. It is a trial and error approach that may produce different solutions in repeated runs. It is often too long and a complicated process, difficult for people to understand. Each application of simulation is ad hoc. The simulation model does not produce any answer by itself. The user has to provide all the constraints for the solution that he wants to examine. And in the last, the Monte Carlo simulation, Monte Carlo method is a substitution for the mathematical evaluation of a model. Darker and Kick define Monte Carlo method as combination of probability methods and sampling techniques. So in short, Monte Carlo technique is concerned with experiments on random numbers, and it provides solution to complicated operation research problems. We will also see how to generate the random numbers with the help of simulation. So application of random numbers, simulation of natural phenomena, sampling techniques, that three will combine, and we are able to generate the random numbers. Then we use it for numerical analysis, for computer programming and decision makings, and for recreation of data. So class, this is all about today's lecture, or the lecture that will held on the 23rd of January. Till then, thank you, and I am hope and sure that these slides will give you us just a concept and idea that what is going to held in the class. So, Khuda Hafiz till then, and Allah